Hello, programmers. Today we're going to talk about variadic functions in C++ 11 or later, but first we're going to review a little bit about how you can have a variable number of arguments to functions in C. So most functions that we've dealt with have a fixed number of parameters or arguments that they're dealing with. So this function print hello world doesn't take any input arguments. If you try to pass something in the parentheses when you call that, then it's not going to compile. The function test here takes 3 input arguments. If you try to pass in 4 arguments or 2 arguments, it's going to give you a compile error. But there are some functions in C that do take a variable number of arguments. One example of a function that takes a variable number of input arguments is printf. So we have called printf where we only pass in one array of characters that we want to print. We could have a placeholder for 2 variables or constants that we want to print. Then we're printing 2 things. We could try to print 3 different characters. So the number of input arguments, the things in between the parentheses, is variable with printf. It's not hard-coded that you have to pass in a certain number of arguments. We can write functions like printf that will take a variable number of arguments. We'll start with the C way of handling this issue. You'll include standard arg.h if you're programming in C. If you're programming in C++, C standard arg, which has a wrapper around the C header. And to support the variable number of arguments, it's got an internal type var list, which can be used to reference all the arguments one at a time, and then some macros. There's a var start that will initialize your argument of type var list and enable you to be able to access it one at a time through this var arg function. And at the very end, when you're done, you can clean up with a var end. Let's see an example. In this little example, I've got a function print numbers, and I've got this ... which could include as many arguments as you want to pass into this function. So if I call print numbers and I really want to pass in 1, 2, 3, well, the 1, 2, 3 are going to go in that ... and I've got an argument that's just an integer that will help me figure out how many arguments you're passing in. So if I'm passing in 1, 2, 3, we'll actually pass in 4 arguments because we're going to start with the number 3. If we just want to pass in 100, then we'll actually pass in 2 arguments. The first one is just a normal integer. The next one ... We're going to be able to unpack that and take a look at each of the items that we're passing in. Here we've got this internal type var list, and it's going to be a data type, and args is the variable of that type. If you put a breakpoint here and we go ahead and run it, then the variable args at this point isn't actually set to anything useful. So I said if I print what is args, you can see that it's a little bit more complicated than just a normal integer. But after this var start, if I step over that line of code and then I look at args, we are actually initializing some information here. So we'll be able to, one at a time, look at those arguments. I don't really care too much about the internals of this, but let's just talk about the different macros. So this macro is allowing us to look at these items one at a time. We need to have the variable name of type var list as the first input and the number of items that are in that list second. And we know the number of items, so we can go through a for loop num times and go ahead and individually look at each of the integers that we're passing in and then go ahead and print them out to the screen. Once we're done, we're going to do some cleanup with var end. So let's go ahead and run it. I ran it twice, once where I wanted to print 1, 2, 3, and next with 100. Now there's some drawbacks to this C way of doing a variable number of arguments. Notice that all of these have to be integers the way that I've written this. If I were to accidentally change one of them to a floating point, another one to a character, this isn't going to maybe behave the way I'm thinking it will. I'm still passing 3 things in, but look at the 3 things that it's printing, so you may not get the behavior you want. Another thing is, let me switch this back to 3 integers, is passing in the number of items. What if you're not paying attention and you update, let's also print 4 and 5, but you don't update the number of items here, well, the function's not smart enough to realize that you're actually trying to pass in 5 things, so you're only going to end up printing the first 3. We can fix some of these shortcomings when we move over to the C++ way of handling a variable number of input arguments. Let's move over to C++ and template functions. So we've seen, and I'll put a link to my template functions video if you haven't seen this before, but we've seen how you can have a placeholder for the data type that your function is going to be using. You can have one data type that you've got a placeholder for, or 2 data types that you have placeholders for. 3 data types that you have placeholders for. Use a ... here that is going to be a placeholder for many different data types that we might be having. So in this function, it's not quite the same as printing all the numbers. We'll get to that later, but I just want to show how I've got this placeholder, this ... placeholder, and that is going to stand for a parameter pack of different data types. So we don't know how many different data types we're getting, but we're going to look and use a version of size of that can look at that parameter pack and tell us the size of it. So let's see what that looks like in code. And I switched over to C++ 17 because some of the folding expression stuff I'm doing later is going to need C++ 17. So this ... we've got a pack of things that we're using in this function. They may be different data types. We will take a look at the size of this. I can try calling the function with no input arguments, and that'll work. I can try passing in 2 and 3 and 5 different input arguments. Let's experiment with the data types. This threw us off when we're using the C version of the code, and no problem. We can still count the number of data types even though there are different data types that we're passing in. And here is a very nifty way in C++ 17 or later to print all the numbers when you have a variable number of inputs to the function. So advantages to this, I don't need to reserve the first argument to the function for the count. I can just add and subtract arguments as I want to. We can even pass in arguments of different data types. So let me put something that has a decimal point. I'll put a string. I'll put a single character, and I can add as many values as I want, and it's able to handle them all and print them all. So we look and we've got more than one data type that we're passing in here possibly, and then we are going to go through one at a time and print the argument, a space, and this ... we are using the comments on the wrong line, but we are using what's called a fold expression. If you want to Google search fold expression, it's a way to apply an operation on each of the arguments in your parameter pack. And that's the parameter pack. So I've got all my arguments in args, and one at a time I'm going to print them and put a space. Here's a very common example you'll see when people are talking about fold expressions. In this example, I'm adding 1 plus 2 plus 3, and again, the ... in my first use means there's more than one argument type that you could be passing in, and we can try changing one of these to something other than an int and see what happens. And then the second ... is saying that I've got a pack of arguments, and they're any of these types that we've got placeholders for. And we're going to apply this function to all of my arguments. What does it mean if I have the ... on the right side of the expression, which is called a right fold, versus I'll also show what happens if you have the ... on the left side of the expression, the left fold. And it's like if you're doing an addition and you put the parentheses first around the 1 plus 2 part and add that first and then add 3, versus if you put the parentheses around the 2 plus 3, add that first and then add 1, makes absolutely no difference when you're doing addition. But then we'll try it with subtraction and see that it definitely does make a difference. So same answer, either one here. Let's just see what happens if we switch the data types. And doesn't seem to have a problem with that. Let me get even more radical here and do 65 is the ASCII value of capital A. So it's going to convert that into an integer, be able to add the integers and the floating point number and come up with the right answer. So let's see what happens with subtraction. And we try it, and with the right fold, we are first going to put the parentheses around the 2 minus 3. That gives us a -1. And then if we do 1 minus -1, we've got 2. That answer makes sense. And then you're going to get a totally different answer if you have the dot, dot, dot first. So that's like doing 1 minus 2. You get a -1 minus 3. Then you've got a -4. So pretty cool. C++ 17 and beyond supports these fold expressions. Happy programming!